Hi, everyone. I'm Doug Black, Editor-in-Chief at Inside HPC. And today at SC21, we're with Evan Burness. He is Principal Program Manager for HPC and Big Compute at Microsoft Azure. And today, Evan will be talking about Microsoft's partnership with AMD. Evan, welcome.
Thank you for having me, Doug.
Okay, great to be with you. So we know that for several years, Azure has taken a pretty aggressive position on HPC in the cloud. Please tell us about how your partnership with AMD supports Azure's HPC strategy.
Great question. We try to keep it simple. Customers, when we talk with them, they want to know what it is Azure can do to help them with their research and business that they can't readily get from traditional sources of high performance computing technology. And what has made the partnership with AMD really good is that focus on delivering a bottom line impact, faster time to solution, lower cost, greater scalability, execution of the latest technologies into market in ways that customers globally can reach to do the work that they're there to do better, faster, and more cost effectively. And I think Azure and the AMD team culturally, from an engineering standpoint, are very aligned in that. And that's really reflective in the focused technology that we've partnered on to deliver through a variety of our HPC products, whether it's CPU-based high-performance computing, GPU-based high-performance computing, GPU and CPU-based remote visualization. AMD has been a really good engineering partner with us. And that is what has enabled us to go before customers and say, with the technology that we're putting together, it adds up into something that is going to help you do your work better than you would otherwise do it. And that ends up being a really compelling bottom line value proposition for our customers.
Okay, so let's talk about this week at the conference. We understand Azure has accelerated its adoption of AMD chips over the last 3 years. Can you give us specific examples of that, including how it's impacting what you're talking about at SC21?
Sure. When I think about, we have a variety of technology partners that and on hardware and software from outside of Microsoft, and obviously we have a wonderful engineering organization inside of Microsoft. But when I think through sort of the biggest accomplishments we've had over the last 3 years or so, and what that list looks like, AMD has been on a sort of key partner with us on a lot of those accomplishments. It started when AMD CEO, Dr. Lisa Su, stood up at Computex in 2019, I believe it was, and sort of shocked the world and said that Microsoft Azure had run the world's first 10,000 core MPI job on a public cloud provider with AMD's first generation EPYC technology based on the Naples processor in our first generation Azure HBV series. And we got a lot of attention when AMD launched the very successful Rome processor, the second generation EPYC technology, because Azure was very fast out of the gate with both it, but also pairing it with 200 gigabit HDR InfiniBand. And when we launched that product into GA, we got a lot of people's attention because we showed the ability to run an 80,000 core weather simulation using WRF at very high levels of scaling efficiency, well above top 25 supercomputers. And I think that was when it clicked both for us and with customers that a lot of the talk and the hype was real. Azure was quite serious about being in the supercomputing game and providing that level of capability, not just as a one-off sort of systems provider, but making that a globally accessible capability and doing that on the back of best of breed technologies with folks like AMD's CPU folks and the folks who provide us and partner with us on the EPYC product line that we've inserted into that HB series. And then I think we really hit our stride is this last year where, or when rather, AMD launched the third generation EPYC processor and Azure was the only entity really anywhere who was operationalized with Milan day and date in an HPC-centric product. Most of the customers we've talked to still haven't gotten Milan at all into their data center. And that technology was launched, coming up on 9 months ago. And not surprisingly, our third generation HB product line with AMD EPYC has been our most quickly adopted ever. When we talk with customers about what's driving that, what's the differentiation, customers keep coming back to it. It's simply a time and time equals money, time equals impact equation for them, which is we have best of breed technologies that they don't, or we're getting them faster than they are able to source them. And when they think about what's the best platform for me to get my work done with, just what's the right tool for the job, and they look at a set of available alternatives, the Azure HBV3 series of virtual machines with EPYC third gen processors is simply standing out above what customers have for themselves on premises and what they are finding available from public cloud provider alternatives. And again, that's just on our CPU side of things. We have a number of other instances where AMD has really come in and partnered with us in really deep and rich ways on the engineering side to improve either performance or cost performance. We have remote visualization solutions based on that. Our 4 entries that landed on the top 30 of the top 500 in June of this year are all based on host platforms running AMD EPYC second generation processors that are delivering really good memory bandwidth and interconnect performance for these scale out GPU AI supercomputers. So the partnership there that was very rich and benefited us, but much more importantly, our customers in very tangible ways across a range of products for the last few years. And how that, I think we're really cresting right now. We're hitting a new high with Azure's introduction of the new Milan X processors into Azure that Azure Executive Vice President Jason Zander announced on Monday that are available now in Azure in a preview program and are rolling out to our global fleet soon. The performance benefits there are really, really exciting, and we can't wait to get them in the hands of customers, and neither can our partners at AMD.
Okay. Well, let's talk a little bit about performance improvements this partnership with AMD delivers over against the conventional notion of really having what you might call a static on-prem HPC infrastructure.
There are a lot of benefits, some of which AMD is bringing to the table, some of which Microsoft is bringing to the table, some of which other technology partners are bringing to the table. I think the thing that stands out the most when I think about AMD's contribution is, at the end of the day, like I said, customers, they tend to ultimately keep it fairly simple, which is what tools enabled me to get my work done faster and with greater cost efficacy. They're pretty bottom line in that way, because the HPC is a means to an end. We don't lose sight of that. It's not the focus of what any customer is there to do. It's a tool in the toolbox, and they want the best tool to get their job done. They're professionals at what they do. And AMD's really had best of breed technology where you look across, measure performance across a broad range of applications, from fluid dynamics, explicit finite element analysis, even implicit finite element analysis now, weather simulation, seismic processing, reservoir simulation, molecular dynamics. The list goes on and on. AMD has had really, really compelling performance and performance per dollar for the last several years. That's reflected not just in sort of the performance that Azure is demonstrating with that technology, to AMD's sort of significant credit. You see that reflected in, say, share of things like the top 500, or how commonly it's been a platform of choice for a lot of the newest supercomputers being released. So I think you see it across a broad range of scenarios and customer environments. I will tell you that 2 things really stand out in terms of how our partnership with AMD has, in very specific ways, manifested insofar as benefits for customers. The first one sort of ties together with something I said before, which is the ability to have the latest and greatest technology for high performance computing when customers themselves often do not. Since we launched our third generation HB virtual machines with the Milan processors, we get into we had a lot of customers come to us that want to run a competitive performance analysis of Azure as compared to the environments they have on premises and even environments they see in other public cloud providers. This trend started before that then, but since we launched Milan, we have not lost a single competitive benchmark. The value of having the latest technology to run these workloads ahead of when others can is materially differentiated. And so for customers, the big win for them in terms of the partnership they have with Azure and the partnership we have with AMD is the ability to allow the customer to focus on their work, knowing that Microsoft is consistently giving them the absolute best tools that exist to do their work. That's the first one. I would say the other one is simply that because of the fact that we can put this technology, we can distribute it all over the globe at really, really large scale, much larger than the vast majority of our customers would have on site for themselves. It's really unlocked a lot of our customers to not constrain themselves in terms of how they are scaling their problems. The ability to now look at every problem you're dealing with across the stack of your business and say, okay, how many of these problems can I run 10 times faster, 20 times faster, 40 times faster, as a function of Azure having best of breed technology from a compute layer coupled with our best of breed InfiniBand networks. That's something where we see customers consistently not just migrating workloads into Azure at the same level of scale, but then once those workloads are into Azure, they start to run those applications at much, much larger scale to solve problems disruptively faster than they would otherwise, which has such an enormous impact on time to science, time to solution, time to market.
Okay, great stuff. So really, Azure is working to change conventional thinking about on-prem HPC versus HPC in the cloud. What are some of the most common customer questions you get regarding HPC in the cloud?
Well, we're mindful that HPC in the cloud, in the grand scheme of things, is still the new kid on the block. This was a thriving community that's been doing amazing work for a very long time before the public cloud came about. So while there's a lot of experimentation with the cloud, and you can see that reflected in a lot of market survey data that gets published, there's an awful lot of folks who are still relatively new to seriously using the public cloud for high performance computing. So there are more introductory questions than you might imagine. There's a lot of folks who really start out with the conversation and with a sort of a basic, can I really run my workload at all in the cloud or at a level of performance or cost that makes sense? And that's fine. It's perfectly fine. We're still, HPC in the cloud is still ultimately, pretty young in the grand arc of history. And as I said, we go through a lot of those exercises with many customers, and we're having pretty good success rate in terms of making believers out of folks. I think that the common questions that are increasingly popping up is as customers start to get comfortable with the platform and they better start to understand the true costs of using cloud as opposed to thinking through the true costs of doing high performance computing purely on site. Is they start to ask questions about how they can essentially decompose their end-to-end architecture that was sort of fixed or confined in certain ways on premises as a function of certain things you just have to take for granted that in the public cloud you would not. In the public cloud, for example, there's no particular limit on the number of clusters you can have or file systems you can have. You don't need to funnel everything into a centralized single cluster architecture or a single file system or data store architecture. You can be very heterogeneous. You can give different teams different kinds of tools. And we have customers very quickly start to ask us questions like, well, do I actually need to have one file system, one cluster? How can I decompose these things? Can I give resources available to a single team that might be in one region globally, but they might want to do, say, remote desktop work locally for latency reasons, but they might be using compute instances halfway across the planet. And those were conversations they weren't even having historically internally because they didn't have the same sort of global deployment of IT infrastructure to support that kind of work model. And then I think the last thing that I really see where customers ask questions, and it's a collaborative one with Microsoft, is they start to ask the question around, wow, what if I could solve these kinds of problems orders of magnitude faster than I was doing it before? That's a big one. That's a really big one. When all of a sudden, you have one aspect of your business that can run 10x or higher faster, that forces you to reevaluate certain other assumptions you have in your business. And it forces customers to then have to think about, how do I value time? What is the specific value to me as a researcher, as a scientist, as an engineer, as a business leader of time? Because they now can clearly see that they can get to the results much faster than they would be able to otherwise. They can explore a much wider design space. And they've had constraints in doing that on site. And they're not getting rid of on site. This isn't a statement about HPC has no place on premises. It clearly does, and it will for an indefinite horizon. But there are certain capabilities one gets in the public cloud when you can not only run HPC problems faster than you could on site, but you can run them at dramatically larger scale in many more places with no particular constraints around the available capacity that you've got. That opens up a whole line of questions and thinking where customers really challenge the assumptions of what they have. Probably, if I think of one more that really stands out that I think the public cloud still has room to improve on, is how do we help customers make clearer sense of all the data that they've got generated out of these simulations? Like, we have lots of customers that say, what is the rational intersection of AI or machine learning techniques with high performance computing, modeling, and simulation workloads? We just published a really compelling customer success story with Vestas, who is a wind turbine manufacturer. And they're one of the largest manufacturers of advanced renewable energy wind turbine generators in the whole world. And they're partnering with a company called Minds AI that runs coupled CFD calculations with AI workloads to figure out how to make sense and make better business decisions on top of the data coming out of all of those simulations faster. I think a lot of customers are now in that mentality where they're going, okay, how do I make the next step? I've made the mental leap. I can use cloud for HPC. I can see it's really fast. I can see that the costs are always going down. It's already very competitive what I could do, on site. How do I then take Microsoft's excellence in the AI and machine learning realm, and how do I absorb some of that as a customer to make my business smarter?
Okay, great review. Thank you. Well, we've spent a little time with Evan Burness of Microsoft Azure talking about HPC in the cloud. Evan, we'll just wish you a very successful SC21.
You too, Doug. Thanks so much for taking the time today.
Thanks a lot.